So I'm a little bit behind on videos, but I thought that rather than be overwhelmed by needing to make up all of these videos at once, I would go ahead and make the video for where we are now and try to go back to the older videos when I have more time. So this is what we will be going over in class tomorrow, Monday, April 29th. For our warm-up, we have Jalen flips a coin. What is the probability it will land on heads? And this is a simple probability. We've already learned this. The number of possible outcomes is 2, heads or tails. And the number of ways to get heads is 1. There's one side that has heads, so it's 1/2. Probability that it will land on tails, same. There's 2 possible outcomes. Tails is one of them, 1/2. What is the probability it will land on heads and then tails? And this is a challenge. I'm kind of trying to get the kids to stretch some because they'll have to think about this. First, you have to think about all the possibilities. It could be heads and then heads, or it could be heads and then tails, or it could be tails and then tails, or it could be tails and then heads. So there's 4 possibilities. And the one we're looking for is heads and then tails. So this one, so that's only one of the possibilities. So it's 1 out of 4. And this leads directly into what we're learning today, which is we're going to define and differentiate between simple and compound probability. We'll count possible outcomes to determine compound probability, and we will identify and practice using a shortcut for compound probability. And you can already see the homework that's due today and that's due next time. So some definitions. So far we've practiced finding simple probability. For example, if you flip a coin, the chance of it landing heads up is 1/2. If you roll a normal number cube numbered 1 through 6, and the probability of rolling an even number is 1/2 because it's out of 1, 2, 3, 4, 5, 6, half of the numbers are even. The probability of drawing the ace of hearts from a deck of cards. Well, there are 52 cards in a deck. One of them is an ace, so 1 out of 52, ace of hearts, so 1 out of 52. And the probability of your name being drawn from the class bucket. Well, it depends on the class, but for instance, in 8th period we have 13 kids, so that would be 1 out of 13. In 1st period there are 11 kids, so that'd be 1 out of 11. In 4th period there are 30, but one of them is out of school for a few months, so we'll call it 29, 1 out of 29. 5th period has 31, 1 out of 31, and 6th period has 28, 1 out of 28. So it's just the number of students in class on the bottom, and you're looking for one name, your specific name, and that goes on top. Alright, so now we're going to explore compound probability. In class I will ask students for what are some ways they've seen compound used, because they will have probably plenty of examples. For example, there are compound words, like doghouse. For example, you might also hear in science, a compound is 2 or more things put into one. And you might hear compound the problem, which basically makes it worse by making it more complicated. Oopsies, problem can spell. Alright. So with that in mind, a compound probability is a probability of 2 or more events occurring simultaneously, meaning at the same time, or in a specific order. So, some examples. I roll a die and spin a spinner. I flip 2 coins at the same time. I roll a die once, then roll the same die again. I pull a piece of candy out of 2 different bags. The probability of 2 students coming from different parts of the building, both being late to the same class. I'll ask the students to come up with their own down here. It can be something simple, like spinning 2 spinners, or it could be something more complicated, like the probability of 2 students won. Now we're looking at the long way of finding compound probability, and we're going to use that to get to our shortcut. So just like simple probability, compound probability is all about possibilities. So if I have a coin and a spinner it has 3 options, 3 possible outcomes, and the coin has 2 possible outcomes. So we're going to look at some simple probabilities for each first. So on the spinner, the probability of spinning blue is 1 out of 3. On the coin, the probability of getting a tails up is 1/2. But when we talk about compound probability, we're talking about if we spin the spinner and flip the coin at the same time, what are the possibilities for what we could get? Well, I'm going to use heads and tails as H and T, and I'm going to use G, R, B for green, red, blue. So we could get heads and green, or we could get heads and blue, or we could get heads and red, or we could get tails and green, tails and blue, tails and red. Different ways that these could fall out together. So the probability that I'll spin blue and flip tails, I'm looking for T and B. So that's this one right here. So that's 1 out of 6 possibilities. Same thing, but with rolling the same die twice, a normal 6-sided die. I'm going to use a table to organize our possibilities. So we're rolling the same die twice. So let's say we roll a 1 on the first die. The second die could also be a 1. But if I get a 1 on the first one, the second die could be a 2. Or it could be a 3, or a 4, or a 5, or a 6. And that's just if the first die is a 1. But what about if the first die was a 2? Then we get all of these other possibilities. We have to go through each possible one. And this is why I call this the long way. As a matter of fact, I'm going to pause this and fill the rest of the table in and then turn it back on. Alright, so now I have my whole table filled out. And I have all the possibilities for rolling a 1 first, a 2 first, a 3 first, a 4 first, a 5 first, and a 6 first. And I also could have done it the other way. I could have done with all the 1s here and 1, 2, 3, 4, 5, 6. Doesn't really matter as long as I make sure I get all of the probabilities by the end. So on a single roll, the probability of rolling a 4 is 1 out of 6 because a die has 6 sides and one of them is 4. And on a single roll, the probability of getting a 3 is also 1 out of 6 because one side says 6 and there are 6 total sides. But then we get to what is the probability of rolling a 4 and then a 3. Well, on our table I can see that that only happened one time, 4 and then 3. Out of, well, let's see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 by 6 makes 36 possibilities, so that's 1 out of 36. Right. We can also do more complicated probabilities, like on a single roll, what's the probability of rolling a 2 or a 3? Well, that's 2 possibilities out of the 6 possible sides, so 2 out of 6 or 1/3. And on a single roll, what's the probability of getting an even number? Well, we already talked earlier about that being 1/2, because half of the sides are even. But then what is the probability of rolling a 2 or a 3 and then an even number? Well, when we use our table, this gets really complicated, but let's go ahead and do that. So we have to look at our 2s and our 3s. And on those, we have to look at the second one being an even number. So if I roll a 2 and then an even number, these are my possibilities. If I roll a 3 and then an even number, these are my possibilities. And those are the only ones, because all the other ones don't have 2 or 3 at the beginning, or they have an odd number for the second roll. So that's 6 possibilities out of 36 total possible outcomes. And 6 out of 36, if I divide by 6, gives me 1/6. So we're going to look for the shortcut in class, but what kids should be able to notice is that you have 1/3 and 1/3, and 1/2, and our outcome for the compound probability was 1/6. And then here we have 1/6 and 1/6 made 1/36, and 1/3 and 1/2 made 1/6. It's multiplying. So find the simple probabilities, or the independent probabilities, and then multiply. And we're going to do some practice. This is the supported practice. We do this together. You roll a single die numbered from 1 to 6 twice. What is the probability of rolling a 6 the first time and an odd number the second time? So this is essentially the same thing we just did. So the first time is the probability of rolling a 6. That's one option out of 6. The second time is an odd number. So we know that half of them are odd numbers, so that's 1/2. And then when we multiply to get our compound probability, we get 1 times 1 is 1, and 6 times 2 is 12. 1/12. And I can go back to my table to check that. I need a 6 the first time, and an odd number the second time. Let me do this one in purple. 6 and odd, 6 and odd, 6 and odd. That's 3 outcomes out of 36. Divide by 3, and I get 1 out of 12. Same thing we just got. Then over here we have a jar contains 12 caramels, 7 mints, and 16 dark chocolates. What is the probability of selecting a dark chocolate, putting it back, and then selecting a caramel? Well, here I even filled in the independent probabilities and then the compound one. Dark chocolate is 16 out of, well, how many total? 12 and 7 makes 19, and 16 makes 35. So 16 out of 35. And probability for caramel is 12 out of 35. And we would multiply. So this one's actually going to be a really big one. We'll use calculators for this. Double check my work first. 16 times 12 is 192. And 35 times 35 is 1,225. So that's a big fraction. Well, the numbers involved are big. Numbers 4 through 14 are placed in a bowl and drawn at random, then replaced after being drawn. What is the probability of drawing the number 14 and then a number less than 12? So there are the numbers 4 through 14. So that's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's 11 numbers. 14 is 1 out of 11. And less than 12 is 1, 2, 3, 4, 5, 6, 7, 8 out of 11. Multiply. 1 times 8 is 8, and 11 times 11 is 121. In a deck of 52 playing cards, what is the probability of drawing a club and then another club? Well, the 52 makes this seem much harder than it is, but we have learned that the suits are each 1/4 of the deck, so there are 1/4 of the cards are clubs. So the probability of drawing a club is 1/4. Probability of drawing another club is 1/4. We're assuming with replacement, or else it gets complicated. So we get 1 times 1 is 1, and 4 times 4 is 16. And I see a lot of kids add the ones instead of multiplying. They'll remember to multiply everywhere else, but not with the ones, so make sure you check your work. And finally, the letters that form the word Mississippi are placed in a bowl. What is the probability of choosing a vowel, replacing it, and then drawing a P? Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. So we're going to have 11 on the bottom of both of our fractions. There are 1, 2, 3, 4 vowels, and there are 2 P's. And we multiply, and we get 4 times 2 is 8, and 11 times 11 is 121. And then, in a deck of 52 playing cards, what is the probability of drawing a card that is a picture card, ace, king, queen, or jack, replacing it, and then drawing either a heart or a spade? So there are 4 picture cards for every 13 cards, because there are 13 cards in a suit. So that's 4 out of 13. And hearts and spades are half the deck, so that's 1/2. 4 times 1 is 4, and 13 times 2 is 26, which can be simplified to 2 out of 13. I'm not going to go over the individual practice. I'm just going to pause, put up the answers, and then unpause so that you can check them. And then I'll flip to the homework so you can see it, and that'll be the end of the video. Okay, so there are the answers. You can see that there are a lot of probabilities that turned out to be the same. That's okay. And then the homework. Just 2 main questions, 2 experiments with some compound probabilities to find for each. And that's it. If you have any questions, you can shoot me an email or call. Just let me know.